Hello everyone, welcome to a new video of Perspective. This topic is materials for amine services. The point of this topic is not just to summarize the materials, but it's actually to see how those materials have been recommended. So the question that I got was, what is the logic behind using the standards that are given for amine services? How is the selection of the materials recommended? Why only those particular materials? So this video is an attempt to answer that question of why. Now, usually we have certain corrosion types which are seen in amine services over the number of years, and depending on the and now when we know that such kind of services are going such kind of corrosion types are going to occur, we try to use the materials recommended in the standards, or which are usually used in the industry. Now, the corrosion types which are usually seen are sulfide stress cracking, or hydrogen induced cracking, or alkaline stress cracking. So the key word here is cracking. It is this word that actually dictates the material selection. Because you have the cracking occurring, the point is to have a material which is strong enough to resist that crack formation. Hence, that strength is then translated in terms of the tensile strength, yield strength, and the elongation, which means the mechanical properties. Hence, the selection of the materials usually depends on how much is the value of their tensile strength, yield strength, and elongation, and does it match the standard required. Now, from experience, we know that the strengths of all of these materials are good. Even so, we still see some amount of such cracking occurring. So, obviously, the standards which give you these quantities are not foolproof. Rather, they require something else. So how do they then refine the material selection? This refining of material selection is done by remembering that the cracking occurs only after there has been some kind of corrosion. Hence, the first phenomenon that occurs is corrosion. Only after corrosion you have the cracking. Hence, the material selection is based on the resistance to corrosion as well. Now, the phenomena in the amine services are summarized over here. So, amine services usually will not have a straightforward corrosion as is seen, such as hydroxide formation or chlorides. It is a bit more complex, which leads to such organic complexes formed, and these organic complexes can actually further form even bigger complexes with the chromium and Fe ions. Hence, these complexes will obviously be formed in all of these materials because all of them have chromium and Fe. It is even more important because in carbon steel there is no chromium oxide film. So the reaction will directly be with Fe and the material loss is immediately seen. Material loss implies that there will be a mechanical disintegrity. The stainless steels will have a chromium oxide film. So the such complex formation will affect the chromium oxide film, and that oxide film will break. Once the oxide film breaks, either there can be a chloride attack or there can be Fe complex formation as well. So once again we have a material loss and mechanical issues. In fact, when there is a material loss in both of these cases, you will not have a thick scaling formed immediately. There will be small pits formed first in the substrate, and it is these pits where the cracking will begin. So when you want to avoid these cracking, you have to consider the environment, and you have to choose the material which is the most resistant to corrosion in the environment. Its mechanical properties may be perfect, they should, if because the mechanical properties are tested in air, they are not tested in these simulated environments, they are tested in air. So the mechanical properties would be excellent, but their corrosion resistance to the environment that is seen in the amine services should also be considered. Only then the actual nature of how the corrosion will occur and how it will lead to cracking will be seen. Now, some of these hydrogen blistering and hydrogen induced cracking are related to formation of the nascent hydrogen. So nascent hydrogen would penetrate the steels and either consolidate at the grain boundaries, or they will consolidate, they will react with the inclusions. So this is something that I talked a little bit about in my hydrogen embrittlement video. Please do check it out in the series. So the cracking that occurs due to nascent hydrogen is going to be similar. So then the materials which are recommended are in this case, they are exposed to the environment, such as hydrogen sulfide which dissolved in water, where you have the formation of nascent hydrogen. The quantity of hydrogen taken up by these materials is calculated, and the effect of this hydrogen taken up is then measured in terms of how much of the tensile stress is reduced due to the hydrogen. So that is one way in which the recommendation of these materials in the standards is done. When you want to select the alloy, you have to start from this stage, not from this stage. You have to start first from the phenomenon, the environment, because not all amine services, not all amine environments are going to be exactly the same. So you have to start from this environment. Check which of these mechanisms are applicable in your particular application. Then go to the most then go to that material selection which is going to be most resistant to corrosion due to these reactions. Once you have this, only after that you can test for its tensile and yield strength in the environment, so that you get a much clearer view of which of these corrosion types is going to occur and if it is actually able to resist it or not. I hope I have been able to answer the question asked. Please do let me know if you have any more related questions. Thank you.